Hi, and thanks for watching. Over the next few minutes, I'm going to show you one way to build a back-of-the-envelope residential land development model. Now, what you'll find is, first off, many of the modules that I include here are fairly simplistic, and that's on purpose. And you can quickly expand those modules on your own to accommodate your particular situation. The other thing is I'm using a residential land development model to teach some of these techniques. However, this is really applicable to any for sale development model. So condo development, maybe mixed use where you're selling off pads. Essentially any development model where you're not modeling to an income producing net operating income, but instead modeling to the completion of a finished product that will then be sold, irrespective of any income that property is producing. So with that, you will see I have the model open. This is the completed version. It's just one tab. I have assumptions and returns along the top here, and then I have unlevered cash flow, levered cash flow, and then I model out separately my capital stack cash flow so I can calculate construction interest for my levered cash flow. And then all of this comes up and is summarized in two return tables and a profit and loss where we can see our revenues from lot sales, our expenses, our costs from building, and some net profit from the project. Now you can follow along, download this file. You'll see here at the bottom that we have two tabs. One tab, project level analysis complete. This is the completed file. And then we have project level analysis template. And here you'll have all of the headings, but none of the formulas, none of the inputs. And that's what we'll be going through today. Now, if I were building this model all the way from scratch, the first thing I would do is I would create my sections. And that way I see where my inputs are. Right, and again, if you're an accelerator member, you're familiar with the framework input, calculation module, output. Well, our inputs go here. Our calculation modules are down below. Our outputs, or the whole reason we're building this model, is up here in this upper left-hand corner. And from a quantitative perspective, these metrics will tell us whether this is a deal we're spending time on. And because this is a back-of-the-envelope model, this is the type of thing you do very early on, before you really dig into a deal. In this sort of business, you might look at 100 properties before you find one that makes sense. And so it's nice to have a very quick model where you drop in just a handful of assumptions and some value spits out that tells you whether this is worth spending more time on or not. So with our inputs, with our labels in place, let's go ahead and enter our inputs. Now, you can follow along by using the residential land development opportunity assumptions file. And here I have really everything that we're going to be assuming in this hypothetical scenario. And so we'll start here on timing. Our analysis start is January of 2020. And then there will be some analysis period. For now, I'm just going to highlight that yellow to remember to come back to it. We'll be calculating our analysis period based on the calculation modules below. And then we have some land purchase. You'll find in the notes that's 1 million. We have earnest money amount, right? So we have some costs. We have land purchase, we have entitlement, and we have construction. Again, it's very simple. So we're not digging into line items for each of these because that's a different level of analysis at the back of the envelope stage. On the land purchase, we want to track what the amount is, what earnest money we think we'd have to put down, some due diligence amount. How much are we going to spend to see if we can close on this deal or not? How long will we spend on that due diligence? 6 months. And again, you'll notice all of the formatting I have already completed here. Closing month. So we're going to say, okay, if our due diligence goes well, we're happy with the deal, we'll close in month 10. And that will cost $20,000. And then acres. And here, this likely would go in a different section if this were a more robust model. Really, this is investment description, acres, 20 acres, and then entitled lots, 70. So there are our land purchase assumptions. or inputs, and those are going to drive some of our outflows, our land purchase outflows. Entitlement, our length for the entitlement is 9 months. The cost for architecture and engineering would be $60,000, $10,000 in consulting fees, another $10,000 in other entitlement expenses. So roughly $80,000 is what we believe it would cost to entitle these 70 lots. Then we have construction costs, and again, this is just one number. It's $25,000 per lot, or $25,000 times 70 lots, 1.75 million. Our construction would start in month 11. 11. And the reason it's 11, if you look at the notes, is it is the following month of whichever occurs later, land purchase or entitlement. So in this case, that would be month 11, or 1 month following the closing of the land. And then the construction length, we think it will take 6 months to build this hypothetical property, these 70 lots. Then we have acquisition and development financing. In this sort of deal, you would get what's called an A&D loan. It funds both the land and the development costs. And the average interest rate would be 6%. The reason I use average here is for this back of the envelope model, we're not going to use a floating rate module. We're going to use a fixed rate module. However, in reality, this sort of loan would likely be floating rate, and so that's why I label this average interest rate. Loan cost of 75%. And so our loan without interest and our construction interest, I'm going to leave yellow because we'll calculate that in the calculation modules below. The other thing to note is because we're at the back of the envelope stage, we're not going to use a robust construction interest calculation module. Instead, we are going to assume that construction interest does not accrue to the loan balance, or there's no interest reserve. Instead, construction interest is paid in the period that it's due, paid by equity in the period it's due. And some of these A&D loans require that, others don't. But from a modeling perspective, it's simpler to do it this way. And so when we're calculating back of the envelope, this is a good module to use. Note that if you were to do it the more robust way, where you have an interest reserve account, there would be slightly more construction interest because you're charging interest on top of accrued interest. But the difference in returns is marginal, not enough really to impact the yes or no decision. So for this stage, we're going to use no interest reserve, or assume no interest reserve. Then finished lot sales. So in which month is our first lot sold? And these are actually outputs. We're going to actually create a line here where we manually enter the lot sales by period. But there is a finished lot value. So what will we sell the lots for? $70,000. And then we'll have some selling costs related to that lot sale. We're going to say 4%. And that would include here 3% real estate commission and 1% in closing costs. And then net value of finished lots. And this is, again, just to visualize. We have a $70,000 lot value. We multiply that by the number of lots. And then we subtract out selling costs by going times, open parentheses, 1 minus our selling cost percent of value. So 4.704 million is the net value of the finished lots after accounting or subtracting out those selling costs. So with that, we have all of our inputs in place. Let's move into our calculation modules. Now, what you'll find is this first section below our assumptions and returns section is called project cash flows. Here we have unlevered cash flows, or cash flows before accounting for debt. And then we have levered cash flows. And to make this simple, rather than breaking the model up into investment cash flows, operating cash flows, and reversion cash flows like I teach in the Anatomy of the Real Estate DCF, instead we simply break out our cash flows into inflows and outflows. At the unlevered cash flow stage, our inflows are just lot sales adjusted for some selling costs, and our outflows are costs related to land purchase entitlement, and construction costs. And the sum of all those, with inflows being positive cash flows and outflows being negative cash flows, the sum of those is called our net unlevered cash flow line. And from that line, we can calculate returns that we care about. Unlevered IRR, unlevered equity multiple, inflows, outflows, and the sum of those being net profit. And those outputs will flow back up into our assumptions section. Then we move into our levered cash flow. And again, it's inflows and outflows, but there are new inflows and new outflows related to the debt. So what inflows happen? Well, financing draws, right? So the loan begins to fund some of these investment cash flow, the expenses. And then in terms of outflows, we have interest expense related to our construction loan. And then we have some loan payoff, right? At the end of, or over some period, we're paying off the loan. And in the case of this model, we assume that any inflows will first go to pay off the loan before being distributed to equity. And so 100% of inflows go to pay off the loan, and it's not until the loan is fully paid off that those inflows go to equity. In practice, there's generally a percentage of inflows or a percentage of net receipts at closing as you're selling lots that go to pay off the loan, and some smaller percentage is paid to equity. And that's a negotiation between the developer and the lender. But again, in this case, 100% of all inflows go to pay off the loan until it is paid off. So understanding now our project cash flows, let's get started with unlevered cash flow. Now, the first thing we need is a header, all right? And a header consists generally of a date at which a period either begins or ends, and then the number that represents that period. And that period could be a monthly period, a quarterly period, an annual period. It could be a weekly period. It could be a day. In this case, we're assuming monthly periods. And since we have an analysis start month and year there, we'll be able to create a header with a date header first. So we'll assume that this is period 1. Now keep in mind, with residential land development models, you usually don't have a time 0. So we'll start with a month 1, unless there's a close of a venture or land closes at the beginning of the analysis. In that case, there would be a time 0. But here we're assuming analysis begins in month 1. So we go EO month. And again, EO month in Excel takes whatever month you say, you choose. So EO month, open parentheses, asks for a start date. So it's going to look at that date. And then it's going to go forward a certain number of months. We're going to go forward 0 months. And then it's going to output the last day of that month. So in this case, that would be January 31st, 2020. And then we're going to come right to the right of that cell and do another EO month. Only this EO month is the previous date, but 1 month forward. Close parentheses. And then right below that, we're just going to enter 1 for month 1, and then a formula equals the previous month plus 1. And then we're going to take those two formulas, Control-Shift right, all the way out to the right, and then hit Alt-H-V-F to copy as formulas only. Now, one thing you'll notice is I go all the way out to the right, that I've gone and I've actually hidden all of the columns from column DU to the far end to the right. And the reason I do that is it allows me to mouse. I use just my keyboard. It allows me to keyboard over here when I hit that Control right arrow, and it doesn't take me to the very end of the worksheet, but instead just to the end of my work. In this case, my analysis period, right? So month 120, I now have a month header. The other thing I want to do here is I want to add a header above at the top of each of my subsections. So here under levered cash flow, it's already formatted for me. I just go equals. I select this cell, and then I hit F4 2 times, and that locks in the row but keeps the column relative. Hit enter. That's month 1. And again, I can just copy this out to the right. And then do the same thing. I'm actually going to select this entire row from month 1 through month 120 with a Control-Shift right arrow, Control C, and then I just come down to this next section under cash flow, capital stack, and I hit Control V. And because I had locked in the row up above, it automatically, or it continues to link to that original month header row. So I have my headers in place. Let's now build out a lot sale module. And this is rather simple. So for now, it is going to be user entered. So I just select that entire section and hit 0 and use Control Enter so that I input 0 into each of these cells. And then right here in cell C25, this is going to be, call it my air check. I want to ensure that the user has entered 70 lots into some sequence of cells within this row. And I do that by coming out here and I type a formula. I'll say equals if, open parentheses, the sum of all of the cells out to the right, close parentheses, if that equals the number of lots in our analysis, then, so comma, open quotation marks, complete. Otherwise, so I hit comma, open quotation marks, incomplete. And right now it shows incomplete. The last thing I want to do is I want to make this cell turn red anytime it says incomplete. Otherwise it will be black. So I come up to conditional formatting. I choose new rule. I use a formula to determine which cells to format. And then down here, I click this up arrow. I go over and I select this cell equals incomplete. Hit enter. And then what this is asking is format that cell when this is true, when C25 equals incomplete, then click format. I want this font to be red. Hit OK, OK, and now it's red. Watch what happens when I have 70 within those, right? It changes to complete. Or you could say 35, 35. Now the sum of these is 70, and this changes to complete, and it changes to black. Okay. The other thing we notice is, we haven't chosen our month at first sale yet. What we do know is that from our instructions it says lot sales to begin 1 month following construction completion. And so if we come back here and we look, okay, construction starts in month 11. So month 11 is month 1 of a 6-month construction length. 12 is 2, 13 is 3, 14 is 4, 15 is 5, 16 is 6. Then in month 17 is our first month for lot sales. And our instructions also say that we sell 7 lots per month. So that would be 10 months to get to our 70 lots. So I'm going to select 10 months, hold shift and hit right arrow 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 10 cells. Hit 7 and then control enter. That will enter 7 into 10 cells. If we come out back to the left, let's check our air check. Yes, we've entered 70 lot sales, starting in month 17, ending in month 26. But that's not all. We also care about which month is our first sale in and which month is our last sale. And why does this matter? Well, the last sale is the end of our analysis period. And that's an important metric for us to understand. So we're going to create a row here that outputs a note where in the first period, if the first sale occurs in that period, it will output a first sale note. And if it's the last, if it's the period where the last sale occurs, it will output a note that says last sale. And we're going to use a nested if statement to do that. I generally don't like nested if statements, but this is really the only way to accomplish, I think, this task. So I start with an equals if, open parentheses, and then our logic test in this first if statement is an and. So there's going to be a combination of things that have to occur in order for the result to be entered here. So we go and, open parentheses, and the first question we have is, does the sum of all does the sum of all sales from the current sale, from the very first period up through the current sale, is the sum of that equal to the current sale? And what that basically says is, have we had the same number of lot sales from the very first period of our analysis up through to the current period as we have in the current period? And that's just really saying this is the first period to have a lot sale. So I go and the sum of that cell through to also that cell, but then I come up into my formula bar and I lock in the very first cell reference. I hit F4 one time, and what this will do is it keeps the second cell reference relative, but the first cell reference absolute, such that as I copy to the right, that range grows. We're just going to ask, is that range equal to the current cell? If it is, and one other, because this is an and statement, and one other thing exists, if the current cell is greater than 0, right? Because the sum of all of 10 cells with 0, if that's equal to 0, well, then that's not the first sale. So the first lot sale. So if those two logic statements are true, comma, then we want to output first sale. So this next if statement looks like this. If, open parentheses, and we're first going to ask, is the sum of the current cell all the way through to the last cell in our analysis, close parentheses, and then we're going to lock in the last cell such that the range shrinks as we copy it to the right. Is this not equal to 0? And, so comma, is the sum of the first cell in the analysis all the way through to the current cell, and again lock in the first cell, is that equal to the total number of lots in our analysis? And then hit F4 on that M8. Now let's close the and statement. If both of those logic tests are true, then we want this to say last sale. Otherwise, to close off that second and statement, let's leave it blank. Hit enter. Now it's blank, right? Because neither of those logic statements are true. But if we copy out to the right, Alt-HVF, as we scroll out, we see our very first lot sale, it outputs first sale. And then our last lot sale, it outputs last sale. And with that, we can now complete the month of first sale. And how do we do that? Well, we go equals, and we just want to end, we use a match, and match is going to output the number of the cell in which the value that you're looking to match exists, or in the range that you select. So we go match, and what lookup value? We're going to look up first sale within this array, starting in month 1, ending in month 120, comma, and then ask for a match type. We hit 0, or an exact match type. And what is it? Well, in cell number 17, or 17 in this array, the value first sale appears. And that happens to be, right, the period. We can remove the highlighting. And then the month of the last sale, well, again, let's just copy that logic, paste it here, and then just change this from first sale to last sale, month 26. Remove the highlighting. So with that, we have our lot sales module. We know when the first sale happens, the last sale, and the user then can enter the number of lot sales in each period, and this cell here will tell them if they have properly modeled 70 lots. Next, let's move then into the finished lot sales inflow. So this is now a cash inflow, and it's pretty easy because we already have the number of lots that are selling in a given month. We just simply go equals. We take the number of lots that will sell in that month. We multiply it by the finished lot value, hit F4 on the finished lot value. Then we have some selling costs, and that is equal to the finished lot sales multiplied by negative selling cost percentage of value, and hit F4 on the selling cost percentage of value cell. And then our total inflows are the sum of our finished lot sales and our selling costs. And remember, we set our selling costs to be negative, so that's why we sum those up. Come out, we copy to the far right all of those, and now what you'll see is first sale, 490,000 in gross revenue minus our 19,600 in selling costs gives us 470,400 in net or total inflows. Next, we can come down to, let's go ahead and do our outflows. So we have land purchase, and under land purchase, we're tracking earnest money, due diligence costs, closing costs, and balance due on the land purchase. Right? And the reason that we have a balance due is the earnest money is credited towards the land purchase. So the balance due is the difference between the purchase price and the amount of earnest money that has been contributed. Now, the earnest money per the instructions goes hard or becomes non-refundable in month 6. And so we're going to assume in our cash flow, that's when that money actually becomes an outflow. And the logic is quite simple. We simply go equals, we're going to use Boolean logic, open parentheses, is the current month equal to the due diligence length there, an F4 on that cell M13, close parentheses. That Boolean logic will either output a true or false statement. And in Excel, true is equal to a value of 1, false is equal to a value of 0. So when this is false, it will always output 0. When it's true, it will output a 1 multiplied by what? The earnest money amount right there. Hit F4 on that, and then copy this out to the right. And what we see is in month 6, the end of our due diligence period, we have a $50,000 earnest money cash flow as an outflow. And then we have due diligence. And due diligence is similar. It begins in month 1, ends at the end of our due diligence period, and the amount is straight line, meaning it's an evenly spent over those 6 months, and it's $25,000. So again, we use Boolean logic, equals. And in this case, we're simply going to ask, is the current month less than or equal to our due diligence length? Hit F4, output, that will either output true or false. Whatever it is, we're going to multiply that by, open parentheses, our due diligence amount, again F4 on that, divided by the number of months that we'll be spending it. That way it's evenly distributed over those 6 months. Close parentheses. That's 4,167. Copy that out to the right. And what we see is for 1, 2, 3, 4, 5, 6 months, we have $25,000 evenly split. Closing costs now happen in which month? In the month in which the land is closed. So again, a Boolean logic equals, open parentheses, ask is this month equal to the closing month, F4 on that closing month. If so, multiplied by the closing cost, F4 on that. And then the ending balance. So I won't copy this out to the right yet to save time. Ending balance is what? Well, it's, again, this is going to be at closing. So we're going to ask, use that Boolean logic, is this month equal to the closing month, F4 on the closing month? If it is, multiplied by, open parentheses, what? Land purchase, F4, minus earnest money already contributed, F4. Close parentheses, and then let's sum all of those outflows. We just use an alt equal sign. That's going to sum all of the cells above, and then we'll copy these cells, paste them out to the right, alt HVF, and now we see in month 10, closing costs go out, the balance due on the purchase goes out, we have a total. Now let's just start doing some air checking. So we have this total column, and I'm just going to sum all of the cells out to the right, and then we're going to copy this down. I'm just going to select the cells where we want this copied, alt HVF, and we see total inflows of 4704, and we can air check that or confirm that compared to the net value of finished lots. So we've modeled this correctly. Earnest money 50,000, that's correct. Due diligence 25, yep. Closing costs, balance due, or a total land purchase or amount spent to purchase the land of $1,045,000. 1 million plus 25,000 in due diligence and 20,000 in closing costs. Let's model out our entitlement costs. So architecture and engineering happens straight line over the entitlement period. So similar to how we modeled out our due diligence costs, we're going to model out A&E, consultant, and other entitlement expenses. So here we go equals, open parentheses, and now we're going to take this cell and we're going to hit F4 two times so that we lock in the row of that month header. And we're going to ask, is that less than or equal to our entitlement length here? Hit F4 on that. If it is, we'll multiply this by our A and E. Actually, let's open parentheses. We're going to multiply that by our A and E, and we're going to lock in the column 1, 2, 3 F4s divided by the entitlement length. Just hit F4, lock in both the column and the row, close parentheses. And because we locked in the appropriate rows and columns, we should be able to take that formula, copy it down twice, hit Alt HVF, and then Alt equal sign to sum up all of that above. And so notice we have straight lined our consultant, our A&E, and our other entitlement expenses over 9 months. We should be able to copy all of these out to the far right such that over a 9-month period, we get 60,000 in entitlement, 60,000 in A&E, 10,000 in consultant, 10,000 other expenses. And then let's just go ahead and copy. We can borrow those cells there. Just copy that down there, 80,000. And there's our air check. Finally, construction costs. Let's actually just copy this down already. So we have the sum of our construction costs. We can watch this. Construction starts in a certain month and ends in a certain month. So our Boolean logic is different here. In fact, here we have an and statement. So we go and, two things need to happen. The first is, we're going to ask, is the current month we're in greater than or equal to our construction start month? Hit F4 on that. Comma, and is the current month we're in less than, open parentheses, the construction start month, F4, plus the construction length, F4. And the reason I just did less than is because 6 months goes from month 11 to 12, 13, 14, 15, 16. And so really we're going to ask if it's in month 17, then this won't be true. But if it's in month 16, it will be. So we go close parentheses on that Boolean logic, multiply that by what? Open parentheses, the total construction cost here, hit F4 on that, divided by the construction length in months, F4 on that, close parentheses, hit enter. And now let's copy this out to the right and we'll see if our formula is correct. And sure enough, month 11, from there, 1, 2, 3, 4, 5, 6 months. 1750. So we have modeled our construction cost correctly. So lastly, we have outflows, and that equals what? Total construction cost plus total land cost plus total entitlement. I missed that one. And we just copy this out to the right as formulas only, Alt-HVF. And we have our total outflows on our unlevered cash flow. With our outflows and our inflows in place, we can do our net unlevered cash flow. So we go equals, and we're going to do negative outflows plus inflows. All right, so in your net unlevered cash flow, outflows are always negative, inflows are positive. Copy that out to the right, formulas only. And what we see is a string of negative cash flows as we're building the lots. And then those cash flows turn positive as we begin to sell lots. Now we can do an IRR calc. We just simply go equals X IRR. What values? That row. And we're going to leave it relative. Which dates? These dates here. And hit F4 to lock those in, make those absolute. Close parentheses. An IRR of 84.89%, which is typical of these sorts of deals. They're short term. What really matters is our equity multiple. And we can find that simply by going, what's the sum of all of the inflows? That's these. And what's the sum of all the outflows? That would be those. What's the net profit? Inflow minus outflow. What's the equity multiple? Inflow divided by outflow, or a 1.64 times. So if we were to have invested $1 in this unlevered string of cash flows, we would get $1.64 back at the end, or over the period. So with that, we've completed our net unlevered cash flows. We can now come up to our unlevered summary and enter first what? Unlevered IRR equals that. Let's link that. Unlevered equity multiple is here. Capital required is our total outflows, right? So if we were to do this without debt, we would need to come up with 2.875 million, and the net profit is that value there. Then we can also, just for visualization purposes, how much per lot do we need in capital? So we take the capital, divide it by total lots, hit F4 on the total lots, so we can copy that formula down. 26,129 per lot in profit, 41,000 per lot in capital required to complete this project. So we've finished our unlevered cash flow section. Let's move to the levered cash flow. And a lot of this is already done for us, right? So finished lot sales, let's start there. Financing draws, for now, we're just going to set this to yellow. Finished lot sales equals what? This row. Selling costs equal, again, that row. And then let's set that to 0, and then let's do total inflows. Our financing draws plus finished lot sales plus a negative selling cost. We can take all of that, copy it out to the right. And then let's sum these columns for our air check. $4,704, which is what we expect since we haven't yet modeled our financing draws. And then outflows, land purchase is the same. That's here. Now notice I summarize the outflows rather than itemizing them again. Entitlements there, construction cost there, and then we have loan payoff and construction, or interest expense. I set those to yellow for now. And then total outflows, copy all of those cells to the right. And then let's just take that formula for our air check, sum those up. Oops. 2,875. Okay, that checks out. And then our net levered cash flow is what? Equals negative outflows plus our inflows. Copy that out to the right. So next, let's go ahead and borrow the formulas for IRR and equity multiple from the unlevered cash flow section. We'll just come down and paste these as formulas only. And we have the IRR and equity multiple on a levered basis. Now, we need the inflow and outflow on a levered basis. And it's different from unlevered. You know, in unlevered, we just simply took the inflow line and we took the outflow line. The issue is with levered cash flow, there may be periods where you have overlap. There are inflows and outflows, and really what you care about is the net, such that if you're thinking about equity contribution required in the deal, you're not necessarily required to fund the entire outflow if there are inflows in a given period. And so here what we're going to do is we'll actually use a sum if. And we're going to sum up only the positive cash flow. So we do sum if, the range is that entire levered net cash flow line. And our criteria is greater than 0. Hit enter. 4704. And then the outflow is the reverse. It's sum if, and we put a negative sign in the front to flip the sign to positive, but we're going to sum all negative cash flows from that line. Criteria, less than 0, and done. 2875, the net profit then is inflow minus outflow. Now, as I think through this, so currently they're the same because we haven't layered in any debt yet. And in our based on our existing assumptions, the inflow and outflow calculation here is correct. However, there could be scenarios where there would be overlap between inflows and outflows. And so I think what I'm going to do, I'm going to take these formulas from the levered cash flow section, and I'm going to come up here and paste them into the unlevered. And the result's the same. However, in the event that there is some overlap, it wouldn't be in this case, but maybe you were to start playing around with this model and you wanted to have some overlap between your inflows and outflows, this will allow your outflows to be net of any inflows, which is going to be a more correct number in this case. So we have our levered cash flows done except for debt. And how do we model debt? Well, we need to model the entire capital stack, both the equity draws, equity balance, and the debt draws together with the debt balance, which will allow us then to calculate interest and then link to those in our levered cash flow section down into the capital stack cash flows. So let's start with equity cash flows. What we have here is we're going to track available balance of equity to be used to cover outflows. Okay, so really what we're saying is, okay, first equity is going to fund whatever expenses are required of the project, and at some point where the full equity requirement has been expended on the project, then the debt would come in behind that and continue to fund through to the end. And so what is that equity amount? Well, it's the difference between the total outflows on an unlevered basis and the loan amount. So let's calculate the loan amount. If we come back up here, you'll recall from the exercise notes that the loan amount is 75% of the purchase price plus construction cost. So we take 75% of the cost, not including entitlement, closing costs, and due diligence. So this formula here, and we can do it this way because there's no interest reserve. Construction interest is paid in the month in which it's due. We just simply take 75% or the loan to cost assumption. We multiply that by, open parentheses, land purchase price plus construction cost, close parentheses. That's a loan of $206.25 million. Construction interest will hold off on. So now we have a loan amount. We come back here, our starting available balance in equity equals what? Total capital required minus any loan amount. or 812,500. The ending balance is equal to the starting available balance minus any equity draws taken. And then the starting available balance in the next month is equal to the ending available balance of the previous month. So what's the equity draw? Well, the equity draw is the lesser of any available equity to draw from and the outflows from that period. Right, so in this case, 13,056. And it's the unlevered outflows. It's not the levered outflows because the levered outflows include interest expense and loan payoff. And those aren't being funded from this available equity. It's being funded just separately from that. And you'll see that at the very end when I talk through the required equity in the deal. So this is equal to the max of, and I use a max so that we ensure that this is a positive number, 0 or the minimum of any equity available to draw on or total outflows on an unlevered basis in this period. Hit enter, and that's 13,056. We can copy these formulas to the right to there, and then grab all of these, pull it out, copy them all the way to the far right. And what you'll see is in month 10, we run out of equity to draw from. And that's because we have the land purchase in that month. In fact, we're short about 300,000. So that now brings us to the debt. What's the starting available balance? It's the loan amount. So we come up here and just link to that. What's the ending balance? Well, it's the starting available balance minus debt draw plus any debt payoff. All right, so this will fund down and then it'll fund back up as the loan is paid off. The available balance to draw on will. Debt payoff for now, we're just going to, let's just highlight that yellow and remember to do it. So the debt draw is very similar to the equity draw. We're going to go equals max 0, comma, and that ensures that we're only pulling positive values. The minimum of what? Any debt available to draw from, or whatever the outflows are in this period. Again, unlevered outflows, minus any equity that was drawn on this period. All right, close parentheses on both of those. Of course, it's going to be 0. And then the starting available balance in month 2 is the ending balance from the previous month. We can copy over the debt draw. We can copy over the available balance. And then let's copy all of these out to the right. And what we should see happen is in month 10, when we run out of equity, the debt begins to draw. And it draws up until month 16, when we stop, when there are no more outflows. You'll see that right here. Outflows end. Loan has fully funded. So the payoff calculation uses Boolean logic as well. We go equals, open parentheses, and we're first going to ask, is there any positive cash flow to be used to cover the loan balance? And if there is, we'll multiply that by the minimum of, and we use the minimum of to ensure that we're not paying off a loan that doesn't need to be paid off. The minimum of V8, the loan amount, we're going to hit F4 on that, minus whatever the available balance was at the beginning of this period, and it's the minimum of that, or any inflow that's available is D30 to pay down the loan. All right, hit enter, remove the highlighting, copy this out to the right, and what we see is as soon as we begin to have positive cash flow, it goes to pay off the loan. And so this here is a representation of the loan now being paid off, right? As the amount of the loan available goes back up to the full loan amount. And we'll see that now when we model the outstanding balance. So let's do this outstanding balance calculation. So the outstanding balance is equal to the total loan amount, F4, minus the starting balance in this period. When we copy this to the right, what you're going to see is as the loan begins to fund up, and by the way, this is the outstanding balance as of the start of the period. And that way, so yeah, there was a loan drawn in month 10, but that was as of the end of the period. So as of the beginning of month 11, we have a loan balance of $312,500. And that's important because for interest calculation, well, let's do that now. We want to be calculating interest on a full month's worth of loan balance. So we go equals, we're going to take the balance and we're going to multiply it by the annual interest rate here, hit F4, divided by 12 to convert it to a monthly. Copy this out to the right. And now we see $59,293 in interest expense. Now I made this little note, construction interest is an approximation, and that's because number one, these loan draws aren't necessarily happening on the last day of the period, and such the interest may be more or less depending on when these actually occur in practice. The other thing to keep in mind is these interest payments are being covered by equity, not this equity, but out of pocket from the developer. And that may or may not be the case in practice. And so the interest could be higher. But again, this is at the back of the envelope stage. So with our capital stack cash flows done, we can just come up and link those to our levered cash flow. So financing draws, those are our debt draws, equal there. Loan payoff, we link that to the debt payoff row. And then interest expense, we link that to the interest expense. The other thing actually I wanted to do really quick, let's just sum up our equity and debt draws and make sure as an air check that these are correct. And they are. Look, if we sum those two together, we get $2,875,000, which is equal to the total outflows on an unlevered basis. So we remove the highlighting, and then we'll copy all of these back out to the right. And what we'll see now is we begin to have what financing draws or those loan draws. We have here loan payoff. We've got interest expense, and now our net levered cash flow, or our net profit, if you will, is less than our net profit on an unlevered basis. And that's what we would expect. However, the IRR and the equity multiple are higher because there's less equity required on a levered basis. Most of the requirement is being covered by debt. And so let's come up and finish now. We've got our calculation modules complete. We can finish up the remaining cells, kind of these yellow highlighted ones within our assumptions section, and then we can finish up our returns and we're done with the model. Construction interest, okay, let's just link that to this cell there. And the reason we do this is now we can see how much construction interest is going to be required to be paid out of pocket throughout the whole period. Then we have analysis period, and that is just equal to the month of last sale. And with the assumption section done, let's go ahead and fill in our returns. Link levered IRR to there. Levered equity multiple to the levered equity multiple cell. So then equity required is equal to the total equity drawn. And then construction interest, which will be paid out of pocket, is found here. And so the sum of these two is roughly the equity that the developer will have to contribute to this deal to make it happen. And then net profit, of course, is here, 1769. And then let's just calculate, we can borrow actually these, the per lot amounts. And then let's do our profit and loss. Gross lot sales is this here, finished lot sales. Lot selling costs, 196,000. We can sum that up to get total income 4704. Great. And then land cost is there. And we can copy down for entitlement and construction costs. Financing costs is the interest expense. Total project cost, we sum that up. Net project profit is total income minus total project costs. And look at that, 1769708 is equal to the net profit that we calculated from our net levered cash flow line. So 2 different ways to arrive at the same number. Another good air check. Our profit margin is our net profit, project profit divided by total income, or 37.69%. And then let's calculate each one of these on a per lot basis. Hit F4 on the per lot. I'm going to copy that, and then I'll just paste these all as formulas only, Alt-HVF. And with that, we've built a back-of-the-envelope residential land development model. Now, again, you'll note that in a lot of these calculation models, modules, they were quite simple, but you can expand on any of them. So construction, for instance, we had one line item. It was 25,000 per lot, and we modeled that on a straight line basis over a 6-month period. You could expand on that module to have virtually unlimited line items and model each one of those line items separately, maybe some on a straight line, some on an S-curve, some on a manual basis. And those would be modules that you expand on. The same with your lot sales. You could have different lot types, and you could have different absorption rates, and you could make it dynamic or not. But the core framework is the same, and that's really what's important here. So I hope that you enjoyed this Watch Me Build. For those that are Accelerator members, please let me know if you have questions in the forum. Otherwise, thank you everyone for your time.